But instead of having descriptive state, now we are talking of inferential state. Let's see that. I think again same. We started with problem definition, we started with research design, we started with collection of the data through our appropriate tools. And collection is maybe primary data, maybe secondary data. Sometimes we are getting primary data, sometimes we are getting data from other sources also if primary data is not possible. So both type of strategies we are using when we are in the process of collection of the data. So important part is whether we are having primary data or secondary data, they are the nature of data is either qualitative or quantitative. Already I have discussed with you qualitative data wherein we are dealing with numbers, wherein we are talking of quantities. So conversion of the concept is there in terms of the quantity. And when we are in the use of quantitative data, when we have collected quantitative nature of the data, stat is playing the important role as far as analysis is concerned. So to have a data analysis of the quantitative data, we through quantitative data analysis, and ultimately whatever problem we started here, whatever problem we raised in our research problem, which we would like to get answer of that by way of having all these steps from top to bottom and up to data analysis, ultimately purpose is to have conclusions, to have findings, to have summarization of whatever we have started with our problem. So it is really getting answer to the stated problem which we have in our research problem. I think already I made it clear in my earlier discussion also that descriptive, again, this is very important aspect. That's why again and again I am putting in front of you. Descriptive means describing situation, describing present situation by way of tabulation, by way of depicting that, by way of describing that data. And already we have talked of center of center of central tendency, measures of central tendency, measures of dispersion, and normal probability curve, and then use of graphical uh, representation of the data. All these are basically under descriptive statistics, and the purpose is very clear. Purpose is that we would like to describe whatever data is available with all of us through collection. Second important part is inferential one. And now you look at the difference here. Here purpose is describing, here purpose is drawing inferences. So make it very clear in your minds that here we are with the purpose that we would like to draw inferences, we would like to draw conclusions based on quantitative data and using stat for the purpose. And this is drawing inferences means, again, I would repeat, predicting or estimation of the characteristics of a population. We are reaching to population. But how we are reaching? Again, question is we are reaching by way of having sample characteristics with us. So we have collected sample characteristics, we have collected data related to the sample. And but we want to estimate, we want to predict population based on that data collected for the sample. So representation is very important part again, I would say. Now look at the inferential stat. Very simple examples are there. One thing, the moment we are trying to use inferential stat, it is very useful and cost effective. How it is cost effective? One reason is very clear that we have not collected data of the whole population, which is quite large, which is quite long. We have simply collected data from the representative sample which we have chosen out of the population. Representative sample is used for drawing inferences. So we are really speaking without going to the population. We are trying to understand the population characteristics by way of analyzing our sample data. And that's why we say large data, though we are not having as far as population is concerned, through that small data which we have collected through sampling process, based on that we are saying that yes, these are the population characteristics. And that's why we say it is cost effective. No need to go for whole population data. Simply go for sample, but sample should be representative. Again, I am repeating that until and unless we are not having representative sample, whatever inferences, whatever predictions, whatever drawing inferences we are undertaking will be all with wrong information. So look at sampling, then only we can say yes, prediction is reliable, prediction is dependable, prediction is perfect as far as population is concerned, that too based on sample. So
अनिल
just
जी
think of
अनिल जी एक सर अनिल जी फुल स्लाइड कर लेना सर, थोड़ा ना और अच्छा दिखाई देगा।
okay, okay,
एंड नीचे से वो नीचे हाइड कर लेना सर, वो वाला भी कई बार ना ऑब्स्ट्रक्शन आती है, जो एक हाइड लिखा हुआ है ना सर, वो हाइड को प्रेस कर लेना
okay, let
और
me
फुल
see.
फुल स्लाइड कर लेना सर,
I
प्रेजेंटेशन में
think, yeah, I'm trying.
नीचे है सर।
Is it हो गया है क्या?
सर
Okay,
नीचे है बिल्कुल, नीचे ना आपको वो मिलेगा, एक साइन है बिल्कुल राइट साइड में, एक नीचे साइन है,
चलिए
उसे बस आप क्लिक कीजिए। हाँ यस सर, हो गया।
click okay. So with very simple example, I would like to explain where it is cost effective as far as inferential state is concerned. Uh, just look at that we have mean marks of 100 students in Chandigarh city. We are known with, we have collected data from 100 students of the Chandigarh city. Mean score is there. Now using this particular sample information, this is sample of 100, and you might be knowing that Chandigarh city might be having total population of more than lakhs, in lakhs also. So based on that mean marks of 100 students, in Chandigarh district, we have identified some sample. 100 students we have identified. We have used the data collection tool, and based on that data collection, we have collected, and now we are aware of mean marks of the 100 students of the Chandigarh city. Using that sample information, mean marks of the student, we can approximately, using inferential state, can predict the total characteristics, total mass of the Chandigarh city based on inferential statistics use. Likewise, let's look at the second example. You randomly selected a sample of 11th grader in your state and collect data on their SAT scores. I think SAT you are well aware that SAT examination was conducted for 11th graders, and sample we have collected and randomly selected a sample of 11th graders based on again that inferential statistics. This is the power of the inferential statistics, that by way of having known data collection of set scores of 11th grader on a small sample, we can estimate the total population of that set students appeared in that examination. Testing hypothesis and drawing generalizations about the population from the sample data. Very important part is, again I am repeating that what we are doing is, by way of use of inferential statistics, we are drawing generalization about the population. Here population generalization is being made based on the sample data which we are collecting, we have collected, but samples should be randomly selected and samples should be true representation of the population. So generalization depends, reliability of the generalization, dependability of the generalization depends on how far you are able to select the sample from the population and nature of representativeness, nature of true representativeness. So this is very important for inferential study. You look at the way, the technique which you have used for sampling. Now, in inferential strat, two aspects are there. One is parametric, another one is non-parametric. What is this parametric? What is this non-parametric? I will. Parametric and non-parametric stats, they are more powerful, they are more useful for inferential statistics data analysis. Look at now when we are in the process of using parametric tests, certain assumptions and stringent assumptions are required to be made with. So before having data analysis, the requirement is that if you are using parametric stat, inferential stat, and parametric tests are being used in inferential statistics, you have to have think of various assumptions. If you are not taking care of those assumptions, probably whatever findings you are arriving at, whatever decisions you are making at may go wrong also. So assumptions are to be satisfied, conditions are to be kept in mind whenever you are in the process of using parametric inferential stat for data analysis purposes. What are those? Observations must be independent. They should not be contextualized. They should not be in context with something that in this situation I am collecting this. They must be independent of the anything around surrounding you. And another very important aspect is, yesterday I have touched upon that normal distributed population. Today again I would like to highlight that whenever you are in the process of using parametric test, minimum requirement is that you must see first of all, you must establish first of all that whatever observations, whatever data we are having, that data is drawn from normally distributed population. So you have to draw a curve there, normal probability curve you have to establish there, and you have to see the nature of that normal probability curve. I have already discussed with you, it should not be bimodal, it should mean median mode should lie on the same point, and it should be symmetrical in both sides. Then only we say that normal distribution of data is there. So also mean, median, mode in normal distribution. Beauty is the moment you are getting mean, median, mode, all the three same, you are very clear in the mind that yes, our data is tending towards normality of the distribution. So look at the data first before applying any parametric test for the purpose of drawing conclusions based on inferential stat. First of all, try to establish that the data is normal. And how we can see that? By way of conducting a test, KS test is there. I think next session, which is devoted to the software, will try to establish that yes, KS test can be used for establishing the normality or otherwise of the data. And another indications are there. Again, statistically also you can establish without going for this particular test. Statistically, if mean, median, and mode are same, you think of normality of the data. Kurtosis and skewness values are close to reference values. You can again look at the data. You can think of the data that data might be normally distributed for that. But if you want to establish through software, you can think of having KS test. KS test is here. This is available in softwares also, and this will draw the chart there, and the chart nature will be normally distributed scores. Sorry. Then one or two observations. What is that? One is independent, and another one is of normality of the distribution of the data. And third one is populations must have same variances. Whatever population we are having, we have collected data from, they are or they must have same variances. Already I have told you what is variance, standard deviation, and relationship between variances is there. So this can be LNB test can be done there, just to check that whatever data we have in our hands, whatever data we are trying to apply parametric test, they are from the same variance. The population is same. Variance means homogeneity, heterogeneity of the data, and we can say. And if data is from the same variance, whether heterogeneous or homogeneous, we can think of that. Sample must be randomly drawn. I think all of you will agree with me that whenever we are having sampling of the population, random sample provides us more chances of normal distribution of the data. So try to select sample by way of having random sampling technique from the population. If randomly you are drawing sample from the population, chances are more and more to go for normally distributed data. So this assumption is there. And third, very important part is always, I think research already now you are aware of. We are talking of this independent variable, we are talking of dependent variable. Now, in this case, one of the important assumption of using parametric test in inferential stat is that dependent variable should be with ratio or interval scale if you want to use parametric stat for testing hypothesis, because we are trying to. So what is this scale? I think need to know there are four types of scale. I will be discussing with you in the next few slides, but one of the assumption required to be satisfied before the use of parametric test in inferential stat is the dependent variable must be in ratio and interval scale. What is this? Let me tell you. When dependent variable is measured on continuous scale, parametric statics or parametric test should typically be selected. So all these are stringent assumptions to be satisfied before really applying parametric test for data analysis purpose from the basket of inferential state. So as against of parametric test, non-parametric tests are there. Already I have informed you. Already I have told you. Now when we are having data not as per the requirement of the parametric test, we should go for non-parametric test wherein no stringent assumptions are required to be satisfied before use of the non-parametric test. What are those? Yes, we will be discussing that. Non-parametric methods are used when population data has an unknown distribution. Distribution is not known. We don't know sample size is also small one. When we are having these conditions for our sample data collected, then we should go for non-parametric test. Another variation from use of parametric test is in parametric test, you have seen that dependent variable should be in ratio and interval scale. Now here, when we are in the process of using non-parametric test, or if we are trying to use non-parametric test, make sure that dependent variable is either nominal or in ordinal scale. If we, or indirectly what we can say, if scale of measurement is nominal and ordinal, you cannot think of using parametric, but you have to go for non-parametric test of, for testing the hypothesis. So parametric, non-parametric, important, again let me summarize, is that whenever our data is normally distributed, is on the scale of ratio and interval, we can use parametric test, and parametric test is a very powerful test compared to non-parametric test. Of course we can think of using non-parametric test also in certain situations, but let me let me tell you very frankly, parametric tests are more strong as far as the decisions are concerned. Non-parametric test is not having that because it is having no assumptions. So reliability, validity, and power of the non-parametric test is big compared to parametric test which we have in our mind. And that is all because of the fact that certain assumptions are to be satisfied for parametric test, then only you can use parametric test. But when assumptions are not getting satisfied, when you don't have normality of the distribution of the data, when you don't have data at at ratio and interval level of measurement, you are bound to go for non-parametric test. This I am leaving. So scale of measurement, how we should decide. Now question is how we should decide whether we should go for parametric test or we should go for non-parametric test. I think scale of measurement, already I have mentioned about that four type of scale of measurements are there, and based on that, whether we are having ratio, nominal, ordinal, interval, depending upon the type of measurement scale, we can think of deciding about whether we should use parametric or non-parametric. Appropriate test we can decide about, that we can identify that my data is in ratio scale, so we can think of going for parametric test. If my data is not on ratio and interval scale, then we can't use parametric test. We have to go for non-parametric test. So scale of measurement and scale decides something. Decides. Now look at why level of measurement is important, because it helps you in deciding about whether to go for parametric or to go for non-parametric. And once you have parametric test, you have non-parametric test applied for the data, you will be able to interpret the data properly, because you know very well that level of measurement of the data is this one. This one means this one. This is scale of measurement, that many times we are simply saying that we will go for nominal scale. Many times we are knowing that data is in ordinal scale. Many times it is interval and ratio. Now the difference is nominal means wherein you are simply saying that we have named that characteristics there. Ordinal wherein we are ranking the data. We are able to rank the data. Attributes can be ordered and can be ranked also. And interval means data where we can think of having distance in between two scores, decided defined distance is there. So distance is meaningful when we are having interval data, and ratio is absolutely where is not only distance but absolute zero is there. We are having minimum measurement scale as zero, absolute zero measurement. If you ask me which one is the most powerful level of measurement, ratio is most powerful measure of measure if you are having data in interval and ratio. That's why I said for parametric test to be used, for parametric test to be used for data analysis purpose, you must have your variable either at measured at interval level or at ratio level, because here distance between the two elements of that, they are, it is defined. Absolute zero is also defined in ratio, but in interval scale distance is clear, distance is meaningful, but it is not from absolute zero. The point of reference is not zero in interval scale. In ordinal, you are simply having ranking of the data, and nominal you are not having ranking even. You are having nominal means you have just named, just for example, my name is Anil. I have just named, somebody has just named me by Anil, and that is the data we have. In ordinal ranking of the information, then ranking of the concept based on hierarchy. Hierarchy means sometimes you may call it that I have ranked the data on the basis of length of the individual. So ranking is there, whether we are having your ascending order or descending order, but some kind of ranking you have done for with that data. And in distance interval, again let me repeat it, interval means wherein we are saying the difference between the two, one or two is one only, two and three is one only, so distance is well defined. But in ratio, zero distance is defined with respect to zero. So this is hierarchy of levels, and that's why we say that parametric test at least require ratio and interval, because where distance is meaningful and absolute zero is also there, which is not available in the lowest level of measurement. Normal curve, again I would like to tell you that parametric stat definitely requires distribution of data in normal curve. So normality, where no skewness is there, mean median is there, it is symmetrical. This side and that side, it is negative side, it is positive side, and cases in negative side from the center is same as, and that's why we say symmetric distribution is there. But when symmetric distribution is not there, mean median modes are different, we say scores, nature of the scores are either negatively skewed or positively skewed. When we have negatively skewed, let me repeat it again, mean, median and mode, they are different. Not only mean, median, mode are different, but from the center, more scores are towards negative side. Negative direction is flooded with scores. So this is negatively skewed. Positively skewed, wherein we say that scores are, cases are more on positive side. That is what we call it as positively skewed. Number of scores lying in the right side are more compared to number of scores lying in the left side. And when this is the situation, we say positively skewed data is there. It is deviating from the normality and cautious. It is giving us caution also that you cannot use parametric tests for arriving at decision about the acceptance or rejection of the hypothesis, or you can say we are rejecting or accepting as hypothesis based on only normality of the data. I think parametric means there are number of tests there. And I think if you just recall parametric test, we say t-test is a parametric test, ANOVA is a parametric test, ANCOVA is a parametric test. I think ANOVA and COVA you might be knowing in detail. ANOVA means analysis of variance, and COVA means analysis of covariance. So t-test, analysis of variance, and analysis of covariance, they are under the category of parametric test. And let me repeat it again. When you are using t-test, when you are using ANOVA, when you are using ANCOVA for your data analysis, try to ensure that your data is normally distributed. Try to ensure that your data is at the appropriate level of measurement. Then only you can go for use of t-test and ANOVA or ANCOVA. But in non-parametric test, very popular test is chi-square test. Here, assumptions are not very strong. Even with non-normal data, abnormal data, you can go for non-parametric test. That is chi-square you can apply when you are having non-normal data. Another advantage of use of non-parametric test is that you can have application of this non-parametric test like chi-squares when data is measured at the level of nominal and ordinal level. Simply you are having ranks. So you cannot think of applying t-test, ANOVA or ANCOVA. But when you are having ranks only, you should go for non-parametric test. Otherwise, if you are forcefully applying parametric test, it will be providing you not appropriate result, not accurate results, not dependable or reliable results. You can use that, but it will not provide that. When our data is ordinal means, again let me repeat it, is ranking of the data is available. Actual scores are not given to us. We are not having availability of actual scores. Only what ranks are available, that this is the rank order of the students, rank order of the respondent. With them we have collected the data. In When our data is ordinal, Mann-Whitney test, U test, Kruskal-Vadia test, Wallace test, Wilcoxon matched pair sign test, all these KS test, all these tests are when your data is in ordinal form. Chi-square is the only test when your data is nominal data. So it is not our choice that we will be going for parametric test or we will be going for non-parametric. Actually it depends on the situation, and at least minimum I would say two assumptions are to be satisfied before using parametric or non-parametric. One is level of measurement, another one is normality of the data. So ensure that our data, what is the nature of the data, and then look at what level of measurement is there when we have collected the data. Depending upon at least these two conditions, we can use parametric and non-parametric. Then within that also nominal ordinal data is there. Nominal data is there. Chi-square test is available. Chi-square, very well you are now sure that this is a non-parametric test. When ordinal data is available, then you can think of non-parametric tests like these many tests, Mann-Whitney and all these things. It's not that we are not having parallel tests in non-parametric level. We have parallel tests also like this. If you are not able to use paired t-tests in parametric domain, parallel test available is because your nature of the data is not allowing you to go for parametric. You can think of non-parametric equivalent of parametric also. Instead of having paired t-test, we can think of Wilcoxon rank sum test. Likewise, instead of having unpaired t-test, we can think of Mann-Whitney u-test. Likewise, I think this is well known to all of us that whenever our data is ratio and interval level, we can think of using Pearson, product movement correlation. But if your data is available in ranks only, I think you know very well rank difference correlation, Spearman's correlation formula is to be applied. So very simple to remember is that Spearman correlation, wherein we are working on ranks of the individuals, is a non-parametric equivalent of the parametric Pearson's correlation. One way analysis of variance instead of one way of analysis of variance, because you are not able to use, depending upon the nature of the data, you go for non-parametric equivalent of that one way analysis of variance, that is KW test. So now question is, think of the parallel test also. Don't force yourself to use only parametric test. Of course, it is a powerful test. It is giving you very reliable and dependable result if you are having parametric test used in data analysis. But use of parametric test, again I am repeating, is requiring certain assumptions, and if your nature is not compatible with the use of parametric, go for equivalent non-parametric tests for the purpose. I think instead of t-test for dependent samples, you can think of non-parametric test as sign test. So parallel test, what I mean to say is, for each of the parametric test, you are having non-parametric test also. Apply that particular test in that situation if your data demands that. But if more than two variables are there, you think of ANOVA. If multiple groups are there, then MANCOVA or ANOVA is there, or non-parametric is KW analysis, KW test. Median test is also one of the non-parametric tests as against a parametric test of ANOVA or MANCOVA. And this is to establish or to compare, to see the difference between two. When two groups are to be compared, this is when multiple groups are to be compared. When you are trying to find out the relationship between the variables, we go for correlation, establishing correlation coefficient. So Spearman correlation is there. Here correlation coefficient is there. Here Spearman's rank difference correlation is there. And instead of that, you can talk of Kendall's coefficient. You can talk of coefficient gamma. You can think of using chi-square. You can think of using PHI coefficient. You can think of using Fisher exact test. You can think of using Kendall's coefficient of concordance. So all these are parallel non-parametric tests when your data is not normal, when your data is not measured on appropriate level. Two variables are categorical, go for parametric. I think chi-square test, very simple test, non-parametric test. Study groups must be independent. Both groups must be independent of each other. Categories or variables are mutually exclusive. These all are the requirements when you are going for chi-square test in as non-parametric test for data analysis under inferential study category. My point of discussing all this is that we make sure that whatever test, whatever data analysis test you are using, whether you are using parametric, non-parametric, whether you are using data based on ordinal nominal scale, or data based on ratio interval scale. Make sure that all the conditions are being satisfied before, whether you go for software based data analysis or you go for manual data analysis. I'm not against of that software based data analysis. Software based data analysis requires your knowledge. First you establish that these points are to be satisfied under this particular test, then only you go for software based analysis of that data. Softwares are giving you direct calculation, but you have to think of which test to be used for what purpose and why I am using that test. So appropriate knowledge of statistical analysis must be there in the researcher before really going for software based analysis of the data. Software will give you some results, but if you are not satisfying assumptions of those tests which you are applying through software, probably you are landing somewhere else, not on dependable results you are landing. I think chi-square is there. This is the formula. Normally we have observed frequency, expected frequency divided by expected frequency will give rise to the value of chi-square. In chi-square, as already I have mentioned, no requirement of scores from interval and ratio. Just ANOVA and correlation because of the nature of these. These can be used with data measured on nominal and ordinal scale. So conditions are there, assumptions are there behind each and every test. Try to satisfy those conditions, assumptions first, and then enter into the process of data analysis, particular test which you are likely to attempt. Likewise, for all the tests, we are having certain assumptions. My point to bring all this in the awareness of you people is that statistical analysis is very simple from the looking point of view, but it requires number of assumptions, number of conditions to be satisfied before embarking upon that particular test. Whether parametric or non-parametric, whether one particular specific test you are using, use that test with the knowledge that yes, I have tried to satisfy assumptions and conditions first, then only I am using them. This is something we can have depth discussion. I am just giving you awareness only because inferential statistics is to be told, to be discussed with hands-on practice only. And next session is provided for that only. So try to capture that. Wilcoxon matched pair sign test is used to test for a difference in mean or median of paired observation, unpaired observation, two types of observations, two type of data are there. Observations or data taken from paired, from the same group. When unpaired is there, means they are different groups. So these are all ways how to calculate that particular test. Two, three more important aspects are there. One is I'm just making sensitizing you because it will not be possible to have discussion on all these things in during this session only. Think of one tail test, two tail test. Certain tests are one tail test, certain tests are two tail test. When you are concerned with both the sides of the normal curve, you in the process of having two tail test. When you are simply going for one direction, positive direction or negative direction. You simply try to test hypothesis which is directional hypothesis, then you go for one tail test. This is what I am taking out now. I will give you some more important aspects. Different two-tailed test, when is to be used? When you are choosing between groups are different. Control group and experimental group, yeah, variation group, they are two different. Then you go for two-tailed test. And when your concern is which one is better over the other, positive directional test is there, then we use one tail test. I think another very important aspect is at what level of significance, which is known as alpha level also, and at what confidence level conclusions. So what should be your level of significance? This is to be chosen by you only. Level of significance means 5%, 10%. When we are saying 5% chance of being wrong, we have decided that this is level of significance is okay for this particular aspect. It is to be decided based on what exactly is your topic and how far you can think of going wrong with that. So 5%, 10%, 2%, 1%, all these chances of you think that if I'm going wrong and 95% I have confidence, then think of that. Normal curve graphically is significance level is here. So this is that. Significance level is here in this. Significance level is both the sides, and the area within that left or right is confidence level. So the relationship between confidence is mathematically we can say confidence level 95% is confidence I have because 1 minus 5% is 95. So significance level and confidence level goes together parallelly. Once you establish that, once you chosen that, only my concern is 95% confidence I would like to say about my results. 90% I would like to say about my results. This is the confidence I have. So depending upon the nature of hypothesis you are testing, for example, if I say in medical sciences, if you are using this level of significance should be too high, it should be somewhere 99.9% confidence, one has to say, because question is of life of an individual. But in education, in social sciences, even compared to science, it is little relaxed. You can go for 95% confidence also, you can go for 90% confidence also, because it is not that crucial, it is not that typical. Likewise, if you are talking of the science also, and if you are setting level of significance or confidence level in science subjects through research, then you think of more than 95. Never you will go for, or never you will like to go for 5% chance of being wrong. You would like to say for 99%, only 1% chance I would like to give for wrong. 99% confidence I would be able to say that. So setting of level of significance and confidence level is researcher's prerogative. Depending, but it is not subjective. Depending upon the nature of the problem you are dealing with, depending upon the nature of problem you have raised in your hypothesis, you decide about whether I should go for 1% wrong or I should go for 5% wrong, I should go for 2% wrong, I should go for 10% wrong, and then decide about. Overall, if you look at Non-parametric is distribution free. It can be used for nominal and ordinal data. Can be used with a small sample, because once you are having a small sample, you can't expect, sorry, you can't expect normality of the data. So indirectly we are saying abnormal data, we can say. Samples when you have drawn from different population can be taken. So paired is not there, unpaired things are there. Likewise, already I mentioned about that non-parametric stat is less powerful. Interactions cannot be tested in non-parametric, whereas in parametric you can think of testing interactions between the two variables in between, inter or intra variations, interactions you can think. Like ANOVA and COVA is helping us in parametric only, helping us to check, to test the interactions. But in non-parametric, you cannot think of testing that interaction. Just to summarize that, I would like to say, depending upon the purpose of analysis, you should go for parametric and non-parametric stat, and how to select parametric and non-parametric depending upon distribution of the data you have, nature of the data you have. So some examples, when your concern is to find out the difference between independent groups, I think, and your data is allowing you to have parametric state, go for t-test. Likewise, difference when your concern, when your purpose of analysis is to find out the difference between more than two independent groups. This is difference between two groups. T-test is there. When you have more than two groups, you should think of analysis of variance or KW analysis in non-parametric. So these are some clues, some suggestions from my side, that whenever you are having a statistical analysis, look at the nature of the data. Depending upon the nature of the data, think of the parametric and non-parametric test. Then keep in mind that what is the purpose of your analysis. Again, keeping in mind purpose of analysis, decide about whether we should go for this particular parametric test or we should go for this particular non-parametric. This is something. Likewise, there are clues there in the literature. There are a lot of clues available in the literature. So my request to all of you is, whenever you are in the process of applying inferential state for testing your hypothesis, for arriving at decisions based on your question objectives, think of varieties. Keep in mind that yes, you should be well aware of that. uh, how what are those variety of tests available in parametric, what are those variety of tests available in non-parametric, and for what purpose these tests are available. Looking into all those aspects, you think of deciding whether I should go for inferential statics with this parametric or with that non-parametric. That is what I would like to say. This is a very big area. I think already you have in your timetable named as one software. I would like to say there are softwares available. MATLAB is quite popular in engineering colleges. You can use MATLAB also for some of the analysis. Tableau is there for data analysis. This is also available. Origin Pro, if your concern is to have graphics, go for Origin Pro. Excel State, best for Microsoft Excel users. Likewise, very popular nowadays is SPSS. Earlier it was not with IBM, now IBM purchased that. So now it is named as IBM SPSS. And this is very popular test as far as social sciences are concerned, as far as researcher working in the field of social sciences are concerned, they can go for SPSS. But it's not that we cannot use for science subjects, for science topics. You can go for science topics also. And beauty of this test is revisions are taking place regularly. And today we have 29th version of the test. In 2022 September, they have released modified, again improvised version of SPSS under the category SPSS 29. R software is also nowadays very popular, and in many of the researchers nowadays we are using R software. This is really speaking a programming language dedicated to state and data visualization. Versatile software is there. Power of data analysis is very strong in that particular software. So think of using R also. Nowadays, changes are there. Instead of SPSS, nowadays people are using R. And in this R software, comprehensive statistical and graphical tools are there. Many tools are available in this R software. So look at that. But my request before use of any software, my request to all of the researchers is first try to think of which test, parametric or non-parametric, you would like to go for. Because no software will suggesting you that you go for this. It is for the researcher that they first decided that I should use this because these are the requirements, this is the nature of the data I have, and based on that nature of data, based on the purpose of that, this particular test is suitable. Then go for software. Nowadays, trend is being like that we are asking some computer expert, some software expert, statistical software experts to analyze that data. And now, when some other person is analyzing that data, interpretation for the researcher is very difficult task. You will not be able to interpret and arrive at conclusions properly if you don't know about how you have analyzed that data. To give appropriateness to the inferences, appropriateness to drawing conclusions, though you may not be doing analysis yourself, you may ask expert to do analysis, but look at why we have done, what is the result, and what we can infer out of that data. Conditions, look at the conditions. I said non-parametric is not so powerful as parametric, means when we are interpreting that non data received through non-parametric tests, we should be cautious enough to say that yes, under these conditions only we will get results. Limitations are there. Within those limitations, interpretation should be arrived at. Findings should be arrived at based on those limitations. So once you have nature of the test in your mind, you will be able to interpret the data in a proper way, in a better way. Many softwares are there, and even in R packages, you can find ggplot2, dplyr, carrot, bioconductor for bioinformatics is nowadays increasing at alarming rate. So biological aspects are to be analyzed. Go for bioconductor. R is a having a vast array of packages, so it's a very versatile tool also. Now I'm stopping at the. Let me tell you one thing very clear. Inferential statistics experience. It cannot you may be having little bit knowledge, but you have to go for before data analysis. Think of the what I am doing, why I am doing that. Now, if you have any question, please. This is all from my side. As far as inferential state is concerned, it's a very comprehensive area. Within 1.5 hours, within 1 hour, we can just make you sensitive to those things, but developing a skill of using those inferential state is difficult in one session. We are expecting more time, devote some more time for analysis, think of inferential analysis, read in the books, Many books are available there for inferential analysis.